Alright, hey guys, my name is Rohan and I'm working with Aazan for the AP problem physics number 7, I believe it is, talking about the two go-karts that hit each other. So as you can see by this diagram, we have a 250 kilogram person and cart moving 2 meters per second towards a cart B, which has a mass of 200 kilograms. The cart is accelerating at a rate of 1.5 meters per second squared to a velocity of 5 meters per second. So part A asks us the total time for cart A to travel the 15 meters distance that is between them. So the first thing that we're going to do is figure out the time it takes for the cart to accelerate from its initial speed of 2 meters to its speed of 5 meters. So that's just simple. VF is equal to VI plus AT. So 5 meters is equal to 2 meters plus the acceleration of 1.5 and then T. So we get T is equal to 2 seconds. So the next thing we want to do is find out the displacement for how when it's accelerating. So that's just going to be D is equal to VIT plus 1/2 AT squared. So we get D is equal to 2 times 2 plus 0.5 times our acceleration of 1.5 plus T squared, which is going to be just 4. So we get our change, we get our displacement to be 7 meters. And then to figure out the amount of time it takes for to make up the rest of the remaining 8 meters at the velocity of 5 meters per second, all you have to do is 15 minus 7 is equal to the velocity, which is going to be 5 times t. So that should be a minus sign there, sorry. So we get 8 is equal to 5 times t, and then we get t is equal to 1.6 seconds. So then all we have to do is simply add these two t values together. So we get 2 plus 1.6, and then we get our t is equal to 3.6 seconds, and that's how long it takes for cart A to reach cart B.
Hey guys, so it's Professor Khan here, and we're going to be working on part B of the problem, and it's asking me to calculate the speed of car A after the collision, and it gives me the final velocity of car B. So what I'm going to use is I'm going to use the formula PI equals PF. Okay, so basically what we're going to do is we're going to add the two momentums initially and then add the two momentums for finally. So we know the mass of car A is 250 and it's going 5 meters per second. And then we already know that car B is going at is at rest. So it has a momentum of 0. So it's going to be 250 times 5 plus 0 equals 250, and we're trying to find the final velocity of car A, so we're going to use VAF, and then plus the final momentum of car B, which is now going at 4.8 meters per second. Okay, so multiply that, and you're going to get... let's use the calculator. 200 times 4.8 gives me 960, and then for this side 250 times 5, it's going to give me 1250, and then 250 VAF. So now we're trying to solve for VAF, so we're going to bring 960 to this side. 1250 minus 960, it's going to give me 290 equals 250 VAF. Divide that by 2, divide both sides by 250, and if all is well, we get our magic number of 1.16 meters per second for VA. Bada boom. Alright, Professor Aazan here forgot about part 2 of the question, and it asks what direction of the direction of the motion of car A after the collision. Now, since we know the velocity here, we know that it's going to be going to the right. So the direction of our motion for car A is to the right. All right. Thank you.
All right, so Professor Rohan back here, the better professor in the group, also known as the on-level physics god, is back with part C. So part C asks if the collision is elastic or not, and the way that we figure that out is compare the kinetic energy at the beginning and the kinetic energy at the end. So the kinetic energy at the beginning is going to be Ki is equal to 1/2 m, which is going to be 250, and then v squared, which is just going to be 5 squared. And that's equal to 3,125 joules. The kinetic energy the final kinetic energy is going to be equal to 1/2 times 250 times 1.2 squared plus 1/2 times 200, and the final velocity of 4.8 squared. So we do some math real quick, and we get 180 plus 2304. And that's equal to 2484 joules. So now we're going to compare our initial and final kinetic energies. So as you can see here, the initial kinetic energy is much greater than the final kinetic energy, right? So we can say that the collision is not elastic.